that we've talked about geometric sequences and we've recognized the patterns, our next task will be to write an equation for the nth term of the geometric sequence. Now this nth term is just code for any term in the sequence. So we're going to write an equation for the whole sequence. Now if we recall from our previous section on exponential functions, the formula for an exponential function is f of x equals a times b to the x, where a is our y-intercept and b is our multiple, our constant multiple. Now we just learned that geometric sequences are the same as exponential functions, so we're going to use this equation and write an equation for a geometric sequence. We do need to change the notation to sequence notation like we did with our arithmetic sequences, but we're going to do that in just a moment. So here's our sequence. I've taken it and I've written it in a table of values so that we can write our equation for it, and then we'll change it to sequence notation. First, we're going to spot the pattern. So going from 0.6 to -3 to 15 to -75 has a multiple of -5. We're multiplying by -5, multiplying by -5. So we have our multiple, that's our b value right here. We need our y-intercept, and if you remember from sequences, we start with the first term. That means that we need to go back one step to find that y-intercept right here. So if we go back one step by dividing by 5, negative 0.6, sorry, by -5, 0.6 divided by -5 is negative 0.12. You may write that in decimal form or in fraction form. Either one will work. So that gives us our y-intercept and our multiple. Let's put it together. We get f of x equals our y-intercept, which is negative 0.12, times our multiple, which is -5 to the power of x. Now, on our sequence, we've used a slightly different notation where we had our x value switched out for n, so that was 1, 2, 3, 4, and so forth. And our y value was switched out for a sub n. So this f of x, which is a y value, is switched out for a sub n. This stays the same, all the numbers, 0.12, -5, they all stay the same, but our x has been switched out for n. And that's the only change between the sequence notation and the function notation. So we're going to try it one more time, but this time with a graph. Now on the graph that I've given you, I have taken the x and the y values and written them as a table of values, but I'm using sequence notation for this. So my x has been switched out with n, my y has been switched out with a sub n. Let's spot our pattern. To go from 224 to 112, we are dividing by 2 or multiplying by 1/2. So here we're multiplying by 1/2, here we're multiplying by 1/2, and we need to go back one step to get our y-intercept. So reversing that pattern, we will multiply this by 2 to get 448. We now have our y-intercept, we have our multiple, and so we can write it as an equation. I'm going to start with function notation again. We get f of x equals a times b to the x. Our y-intercept is 448. Our multiple is 1/2. Make sure to write that in parentheses, by the way. And we have to the power of x. Switch that out for our sequence notation. Our y value has been replaced with a sub n. A sub n is the name for our y value. And our x value has been replaced with n. Now that we have this sequence, we can tackle the second part of our question, which is to find a sub 6. All right, so a sub 6, that just means we're going to plug a 6 into our a value. We get negative 0.12 times -5, but our n has been replaced. It is now 6. So this is finding the value for the 6th step in our sequence. So we get negative 0.12 times -5 to the power of 6. And that gives us 1,875. A sub 6 equals 1,875. Let's try a different one right here. I couldn't, or I don't have to ask you about a sub 6. I could ask you about any step. So let's do a sub 7 instead on this one. That would give us a sub 7 equals 448 times 1/2 to the 7th power. Plugging that into our calculator, we get, parentheses are extra important on this one so that you don't do the calculations incorrect. We get a sub 7 equals 3.5, which you can write as a decimal. You could write this in its fraction form, which would be, let's see, that would be 7/2. You could write this as a mixed number if you wish. That would be 3 and 1/2. Any of those possible answers would be acceptable. Thank you.